Okay, this is Unit 6, Lesson 1. So in this little warm-up section, I'm just going to remind you guys of the perfect squares and cubes and fourth powers that should hopefully look familiar. The squares should definitely be familiar. So we're just going to start listening from the beginning. So 1 squared is 1, 2 squared is 4, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, and 10 squared. And we're out of space there, so I feel like 10 squared is probably enough for you guys to recognize for this unit. The perfect cubes are things like 2 times 2 times 2, 3 times 3 times 3. So something multiplied by itself 3 times. So the first one is always 1, because no matter how many times you multiply it out, 1 times itself, however many times, is always just going to give you 1. And then 2 times 2 times 2, 3 to the third, 4 to the third, 5 to the third, 6 to the third, 7 to the third. So obviously these get much bigger, much faster. 8 to the third, and we'll finish off with 9 to the third. If we had the space for it, 10 to the third is just 1,000. Anything 10 is really easy, just 100, 1,000, 10,000, etc. And then perfect fourth, something multiplied by itself 4 times. So 1 to the fourth is still 1, 2 to the fourth, 3 to the fourth, 4 to the fourth. So these ones get even bigger, obviously, because you're multiplying more times. 5 to the fourth, 6 to the fourth, 7 to the fourth, and 8 to the fourth. That is plenty. These ones get much bigger than the other ones do. So we should recognize any of these, and I'm going to keep putting it back on the screen as we look at some of the problems that we're simplifying. All right, so a radical is not just a square root. It could be a cubed root or a fourth root. So we're going to give you some notational things here. So this is what any radical part looks like. If there's a number written right here, it could be a 3, it could be a 4. We call that the index. And there's an important note down here. If there is no index, like if you just see this symbol right here with nothing written, we assume that the index is 2, and that just means that it's a square root. If you see a 3, it's a cube root. If you see a 4, it's a fourth root. The actual bar right here, we call that the radical sign. So you've probably heard things like, oh, under the radical sign, something like that. And then whatever actually is under the radical sign, we call that the radicand. So it could be a number, it could be an entire expression, but that's what you're actually taking the root of. All right, so let's do a couple quick. So we say give all possible roots. So just figuring out what the roots are, how many of them there are. So the square root of 16. So 16 is in our list of perfect squares. So it is 1, 2, 3, 4 squared. So the square root of 16 would be 4. But something else to keep in mind is that 4 times 4 is 16, but negative 4 times negative 4 is also 16. So we say that it could be positive or negative 4, because if you square something negative, it's still going to come back as positive. So square roots, that's why we always have that positive or negative out front when we're solving these. 121, it's not on our list, but hopefully we recognize that as 11. And so we say that all of the possibilities are positive or negative 11. 289 is also not on this list, but you might recognize that is 17, so plus or minus 17. You guys are also going to deal with some fractions like this. Numerator is a perfect square, denominator is a perfect square. So we start with our plus or minus. Square root of 4 is 2, square root of 25 is 5. So we get this perfect square fraction like that. Next row are cube roots. So 8 is 1 cubed, 2 cubed. But since it's cubed, 2 times 2 times 2 is positive 8, but negative 2 times negative 2 times negative 2 would be a negative 8, not a positive 8. So when we're dealing with cube roots, there actually is no plus or minus. That's very important to remember. There's only one answer when we're doing cube roots. So cube root of 343, that's on our list, and that is 7. So the cube root is 7. The cube root of negative 125, this kind of comes back to what I was just talking about here. Here's 125, so we know it's 5, but it's actually a negative 5, because negative 5 times negative 5 times negative 5 comes out to be a negative number. And then same thing here, we know this is going to be a negative, because there's a negative underneath. And these are both perfect cubes. Cube root of 1 is 1 over The cube root of 27 is 3. Okay, and then last list here, the fourth roots. So fourth root of 1, remember 1 is a perfect everything, so the fourth root of 1 is 1, because 1 times 1 times 1 times 1. But it could also be -1 times -1 times -1 times -1, because if you multiply something negative out 4 times, it comes back to be positive. So the fourth roots go right back to having the plus or minus. So 2401, that is on our list, and that is 1, 2, 3, 4, 5, 6, 7. So that is positive or negative 7. 4096 is also on our list. It's 8. So we say plus or minus 8. And finally, another fraction. We know it's going to be a plus or minus because it's a fourth root. Fourth root of 81 is 3 over the fourth root of 16 is 2. Now pay attention here. They are square roots, but we're not taking the square root. We're taking the fourth root. So make sure you're giving the right answer there. So we're going to take what we just talked about here and summarize it in one nice little table. So the index is the number that's in here, index of 2, 3, or 4. If the index is even and the radicand, or what's underneath, is positive, something like this, you're going to have real answers, just like normal real number answers, and you're going to have 2 of them because we always put that plus or minus out front. If you have an odd index like this and a positive value underneath like this, your answer is still going to be real, but you're only going to have one answer this time, and it's just going to be the positive answer because it started out as a positive underneath. If you have an odd index like this and a negative number underneath, still going to be a normal real answer, but you're only going to have one answer, the negative one, a -5 like that. And this is our special scenario here. We talked about this in Unit 4 when we did our imaginary numbers. If you're trying to take an even root of a negative number, you are going to get imaginary answers like a square root of -9 or something like that. You're going to get imaginary answers, but you still are going to have 2 of them. There's still a plus or minus when you're taking a square root or a fourth root. So just a little summary there. So let's go through and start simplifying some of these. So simplifying radicals, we're going to do the odds. So this one right here, 117, not on our list, but you can play around and see what does go into 117, and it's divisible by 9. It's 9 times 13. So I can split this into root 9, root 13. And so this is very important directions here. If there is more than one root, the radical sign in and of itself means we only want the principal root, which is the positive root. So if there are 2, when you're looking at a question like that, you only give the positive one. So square root of 9 is 3. And then the square root of, this is supposed to be a 13. It said 13 when I wrote 3. So this is the square root of 13. So 3 root 13. We only do the plus or minus when we're solving equations. Okay, if all you're doing is simplifying a radical, we assume we mean the principal root or the main one. Number 3, cubed root, 48. Okay, so if we look at our cube roots, it is divisible by 8, and that's it. So we can break out the 8, and 48 is 8 times 6. So the 2 stays out front. We split this into the cube root of 8s and the cube root of 6. Make sure you write your index every time, because without the index, it becomes a square root, and it's not a square root. So we have 2. The cubed root of 8 is also 2, and then we have the cubed root of 6. So simplify that up. 2 times 2 is 4 times the cube root of 6. And make sure your answer has the index in it, just like the original. Okay, so next page, we're going to look at a couple more of these. So we're going to look at number 5, our next odd question here. We're looking at another cube root. So it's -250. So I know my answer is going to be negative for sure. So for cube roots, we want to see what divides into 250. And it is divisible by 125. So we can split it into -125 and then 2. So you want to keep that negative. That negative is going to come out as part of your answer. So the cubed root of -125 is -5, and then you multiply that by a little leftover piece here, the cube root of 2. Make sure your index is part of your answer. All right, let's look at a fourth root as well. So this, when I'm simplifying it, the 3 is still up front. And then fourth root of 162. So I want to see what divides into 162. Obviously 1 does, but that's not interesting. 16 does not. 81 does. And then it gets too big. Okay, so these are your only options. 81 does divide into 162. It's 81 times 2. So keep your index. We split it into 81 and 2. So 3 is still there. The fourth root of 81, this is 1, 2, 3. So the fourth root is 3. And then the fourth root of 2, always write your index. So final answer, 3 times 3 is 9 times the fourth root of 2. Make sure that index is in your final answer. All right, now we're going to introduce some variables here. So when you are taking square or cube or fourth root, something that's very important, in order for something to be a perfect square, the exponent must be a multiple of 2. So if you kind of follow that logic, in order for something to be a perfect cube, its exponent has to be a multiple of 3. And in order for something to be a perfect fourth power, its exponent has to be a multiple of 4. We did that a little bit in the last unit when we were doing like difference of cubes, sum of cubes, difference of squares. We talked about how those exponents have to be even or multiples of 3. Now we're adding this on, the multiple of 4. So we're still going to do the odds, and we're going to talk about how to break up these variables. So we're going to have 2 square roots. We're going to have the stuff that is a perfect square and the stuff that is not. So start with the number 32. 32 is not a perfect square, but I can split it into 16 times 2. Perfect square, not perfect square. And since it's a square root, everything I want over here is an exponent that's a multiple of 2. So x to the 4th already is a perfect square, so I'm going to leave that here. Y to the 9th is not. So I'm going to take those 9 copies. I'm going to put my biggest multiple of 2 over here, which is y to the 8th, and then that leaves 1 additional copy over here. All right, so let's take our square root. Square root of 16 is 4. Square root of x to the 4th. Think of like what multiplies by itself to give us x to the 4th, and that would be x squared, x squared. So the square root would be an x squared. Same thing with y to the 8th. That would be y to the 4th times y to the 4th. So the square root would be y to the 4th. And then we put our leftovers here. So exponents, remember, have very different rules than what numbers do, because I'm not taking the square root of this 4 or the square root of this 9. I'm splitting it into even versus leftovers. And technically what you're doing, since the index is 2, the trick actually is I take the exponent and I divide it by the index. So 4 divided by 2 is 2, 8 divided by 2 is 4, and then I have all my leftovers. All right, so they'll get quicker and easier as we go through those ones that have variables. So cube root, 216. We are going to split our perfect cubes from the not perfect cubes. So 216, if we go back to our list, 216 actually is on our list of perfect cubes. So we get to bring that just right over here. And then for our exponents, they must be multiples of 3. So m to the 3rd, 3 obviously is a multiple of 3. So there are no leftovers. And then n to the 6th, 6 is a multiple of 3. So there are actually no leftovers at all. So we're going to forget I even did that. These are all perfect cubes, so I just get to take the cube root. Cube root of 216 is 6. Cube root of this, remember my little trick. I take 3 and divide it by 3. So it's just an m. m times m times m gives us m to the 3rd. And then n to the 6th, if I split it into 3 equal groups, 6 divided by 3 means I can take out an n to the 2nd. And that's it. This one actually was a totally perfect cube that comes out without any leftovers. A few more here, finishing off the odds. This one, cube root of negative 64. So I'm going to take my perfect cubes and my leftovers. Negative 64, well, technically 64 is on our list, but I know it can be negative. So 64 is 4 to the 3rd power. So this would be negative 4 to the 3rd power. So this already is a perfect cube. X to the 10th, I need multiples of 3. So 10 is not, but I can take 9 and put them over here, and my 1 leftover copy and put it over here. And then y to the 21st, 21 is a multiple of 3, so all of them get to stay over here, and there are no leftover y's. So cube root of negative 64 is negative 4. Negative 4, negative 4, negative 4 gives me negative 64. And then my little trick, I take exponent divided by index. So 9 divided by 3 is 3. And again here, exponent divided by index, 21 divided by 3 is 7. And don't forget to write your index with your leftovers, and that is your final answer. And then for our last ones here, we move into 4th powers. So we keep our 4th root. Our perfect 4th powers will go here. Our leftovers will go here. So reminder, our exponents must be multiples of 4. So this first one, w to the 4th. Obviously, 4 is a multiple of 4. And v to the 17th. 17 is not, but 16 is. And then I have 1 leftover copy over here. So no numerical part, just variables. So I just do my quick trick. 4 divided by 4 means w to the first can come out of the radical. 16 divided by 4 means v to the fourth can come out of the radical. And don't forget to include the index when you write your leftovers. So that's our final answer for number 15. And we have one final example like this, another fourth root. So for 625, look on our list. 625 already is a perfect fourth power. That is 5 to the fourth. So that gets to stay over here. And then here are my leftovers. C to the 23rd. My exponents must be multiples of 4, so I'll keep 20 of them here, which would leave 3 of them over here. And then D to the 11th. 11 is not a multiple of 4, but I can keep 8 of them over here and the remaining 3 over here. So take my fourth roots. Fourth root of 625 is 5. That's on my list. Fourth root of C to the 20th. Divide 20 by 4, and my new exponent becomes 5 when I bring it out of the radical. And D to the 8th. Fourth root of that would be D to the 2nd. And my leftovers, don't forget to write your index when you write your leftovers. One little trick to make sure you're simplified, these exponents should always be smaller than the index. If it's not, then I didn't bring out a big enough power.